Hi, everybody. This is Mrs. McCulley again with our second installment of Brain Dump for 6th grade. This is what we've got so far. We've divided the periodic table by the amphoteric line. We've marked our metalloids. We've made a key for our metalloids. We've written that the metals are on the left-hand side of the table and the nonmetals are on the right. And we identified the 11 gases and the 2 liquids. And you took your quiz on that. So now we're ready to move on to the next page. And on this installment, I've written everything in red so you can see the difference between what we had last time and what we have this time. The first thing you're going to notice is that we added a lot here in the middle talking about atomic structure. We wrote down that the atomic number equals the number of protons equals the number of electrons, and our little memory device, APE, which tells you that A equals P equals E. We also wrote down that the mass in the nucleus is equal to the number of protons plus the number of neutrons, because those little electrons are so small they don't really count. And we've drawn a little diagram to help us remember where everything is. We have a big fat nucleus here with our protons that are positive and our neutrons that have no charge. And spinning around outside are those itty-bitty electrons with their negative charge. So the nucleus has the most mass. Over here in our little square for the element silicon, we've tried to show that we're going to round all those silly decimals down and make our number a whole number. So atomic mass, which is our whole number, minus the atomic number, which is the number of protons. If you subtract those two, you get the number of neutrons and our little memory device, man. Atomic mass minus atomic number gives you the number of neutrons. Okay, over here on the left, I've circled the numbers on the top of each family. These are our valence electrons. It doesn't matter if it's written as a normal number like we're used to or as a Roman numeral. This number at the top of the family tells us how many valence electrons there are. And remember, the valence electrons are the ones in the outside shell. Now, speaking of shells, we're going to turn our paper sideways, because we have some numbers on the side of the table that tell us a clue to how many shells we have. This 1 shows us this whole period has 1 ring. This 2 tells us that this whole period has 2 rings. The 3 row or period has 3 rings, all the way up to 7 different periods, 7 different energy levels, energy shells, or energy rings. So our periods tell us where our valence electrons are going to live. If they're in row 1, they'll live in that first shell. If they're in row 2, the valence electrons will be in the second shell. 3, they'll be in the third shell. 4 in the fourth shell, and on up. The valence electrons are the ones in the outside energy shell, energy ring. Okay, we're going to turn our paper a little bit, and we're going to talk about the columns or the families. Better adjust my camera a little bit here. So we should see that our groups or families are our columns. me tighten this up so it doesn't come loose again. Well, it did anyway. I'll back this up. Okay, so our groups or families are the columns, and like your family, you share characteristics with your family. All of the groups or families or columns have the same number of valence electrons, indicated by the number on the top. They have similar properties, in other words, they act pretty much the same, and they have similar reactivity. In other words, they bond with other elements in a similar manner. And over here I've labeled that noble gases don't share. They have a filled valence electron shell. They have all 8 of their electrons in that shell filled. So they don't like to play with anybody. They're snobs. Along with that goes the reactivity of an element. Apologize for the noise in the background. They're doing some work in the backyard. Okay, so our reactivity, in other words, how well do things bond or interact with other elements? Well, these families over here on the left are very reactive because they are busily looking for more electrons to fill their outside shell. For example, in this whole family, they only have 2 valence electrons, so they're running around looking for 6 more. But if you look at our halogens over here and our snobby noble gases, they don't need to react so well. They're low reactivity because our halogens over here, they're only looking for 1 electron. Not too hard to find to fill their shell. And again, the noble gases don't like to share at all. So this is what we've been talking about most recently. So we've added this to our table, and I'm going to post this, and we'll probably go over it in class too. I hope these are helping. Next time we will probably be adding just a little bit more to the front, and possibly we'll start on some of the material on the back. So I hope this is helping you. I hope you're remembering it because you really need this for 8th grade. Okay, that's all for now. Bye.